Hello everyone, this is our first visual example related to our lecture where we talked about three different concepts: dimensional homogeneity, dimensionless numbers, and process and data analysis and representation. So this is going to be an example that deals with dimensional homogeneity or unit convergence in equations. In this example, we're going to look at this equation that we have actually already looked at in the lecture itself, where we have an equation d, which has units of feet, is equals to 3 times time, which is in seconds, plus 4. And the first part asks us what the units of these constants 3 and 4 must be. And after that, we're going to cover this concept of converting units in equations. So we want to convert this equation that is in units of feet and seconds into a form that has meters and minutes. So the part A is essentially a review of what we already done in lecture. For this equation to be dimensionally homogeneous, what we need is every term in this equation must have the same units or units of feet, which means the constant 3 must give the 3 times t the units of feet. It must cancel away the units of seconds from the time, which means it must have units of feet per second. And the 4 itself must have units of feet because it's a term on its own. In terms of converting the equation, so now you have an equation that's in feet and seconds. We want it into a form of meters per minute. What you might be tempted to do is this. On the left-hand side, I have d in feet, so I'm going to multiply the conversion to get me from feet to meters by doing so, because it will cancel away. I'm going to do it for the variable on the right-hand side as well. You have time in seconds. I want time in minutes, so the conversion is 1 minute for 60 seconds, and this will do cancel out the units of seconds and give it units of minutes. This might be what you might be tempted to do, but note that this is not correct. And the reason why this is not correct is because for an equation, remember that whatever you do on the left-hand side, you have to do the same on the right-hand side. So in this case, if you do a conversion on the left-hand side like you did, where you divided the term by 3.28, you have to do that same conversion on the right-hand side, or divide the value of 3.28 to both of those terms on the right-hand side as well. So this is not how you would convert an equation. This is typically how you convert a single term when you do a unit conversion, but not for an equation. So for an equation, there's actually two ways you can do it, and I will show you both ways in a bit. The first way is to convert the variables and then do a substitution. The second way is converting the constant 3 and 4 into the units that you want, and then just putting it back into the equation. So here's the first method. I have the original equation listed above again. What we're going to do is convert the variables from feet in seconds into meters and minutes. Rather than doing it into the equation itself, I'm going to do a substitution. So on the left-hand side, you have d in feet. What is d in feet converted to d in meters? So d in feet is equals to d in meters multiplied by this conversion factor, 3.28 feet per 1 meter. Do it for the same for time in seconds. So what is time in seconds equals to for time in minutes? So time in seconds is time in minutes multiplied by the conversion factor 60 over 1. So now what you're going to do is to make a substitution of equations 1 and 2 into the original equation. So now I'm going to replace d in feet on the left-hand side with everything on the right-hand side, which is d in meters multiplied by the conversion factor. Do the same for the time in seconds. If you go back and compare this with the method that I showed earlier that is wrong, it essentially flips all the conversion factors around. So now by doing a substitution, you are not doing things on the left-hand side and the right-hand side separately. And so this is a valid way of doing things. What you're doing is making a substitution for each of the terms that you need to on the left and right-hand side of the equation. From here, I can simplify this equation by getting rid of, by just keeping the numbers. And to clean this up, I can divide every term by 3.28. And now I have the equation in meters and minutes. So you have d in meters is 54.9 times time in minutes plus 1.22. So that's the converted form of the equation. That's the first way where you convert the variables by making substitutions. The second method is to convert the constants 3 and 4. So we know the constant 3 has units of feet per second, the constant 4 has units of feet. We will just convert these constants like we would for individual terms. So 3 feet per second is 3 feet per second, converting this from feet to minute, and then from feet to meters, and then from seconds to minutes, and you end up with 3 feet per second is 54.9 meters per minute. Do the same for feet, the 4 feet. 4 feet converting to meters is 1.22 meters. Now you can see what we ended up with are these two constants right away, right here. And you just put it back into the equation. You don't have to do anything with the variables. These are just variables d and t. So now d in meters is equals to 54.9 times in minutes plus 1.22. Do either way, don't do both. If you do both, you just end up canceling the effects and you end up with the original equation. So that's all we have for this example. In the next example, we'll look at an example of dimensionless numbers, the Reynolds number. So work hard, be smart. I'll see you then.